Okay, hopefully you've done this problem on your own. I'm going to go ahead relatively quickly and run through this. So I know that this is a law of sines problem because when I fill in this data, I have 3 out of 4 pieces of information, and that makes it conducive to law of sines. And I will use the version of the formula that is b over sine b equals c over sine c. But I'm going to try to do a quick picture of this. I'm going to let angle B be right there. So that's angle B, and it's 68.71 degrees. Side B, right here, is longer than side C, and it's easiest for me to draw this picture if I let B be this side, and it's 365.1, and that I let C be this side because it's shorter, and it's easy for me to see that. So this would be angle C, this right here would be angle A, and this would be side A. So it looks to me like side A is going to be the longest side from this picture. But let's forget about that. Let's just go ahead right here and use this information. So let's go side B over the sine of angle B. And let's let that equal side C over the sine of angle C. When you set the cross products equal, you'll have 296.8 times the sine of 68.71 degrees. So that's this cross product right here. And then you need to divide that by the 365. So divide that by the 365.1. And I just want you to know that my notes say that that turned out to be 0.757. Now remember, that's not equal to angle C, it's equal to the sine of angle C. So to find the size of angle C, you've got to go second sine, second answer I hope you'll use. Maybe not just the 757, but whatever the decimal places are beyond that. And angle C turns out to be 49.2 degrees. So I'll fill this in. Now, if I add these two up and get whatever, and subtract that from 180 degrees, I would get here 62 point, it's so odd that I have 0.5, that can't be, I'm going to call it 62.1 is what I'll call it. And then now I can solve for side A by using, I'm going to use A to solve for little a and big B and little b. So that's what I'm going to use. So I'm going to go with side A over the sine of angle A equals side B over the sine of angle B. And then again, I'll multiply these two values together, 365.1 times the sine of 62.1. Those are the two corners where I know information. Then I've got to divide it by what's opposite the letter A, or what's opposite the unknown. And if you don't mind, I'm just going to say approximately side A turns out to be 346.3. I'll fill that in right here. Again, please don't forget to check this over the sine of this equals this over the sine of this equals this over the sine of this with your calculator. I want to move to the next problem and see if I can get the next two done in about 8 minutes or so. This is an unusual situation when the side opposite the given angle, so let's talk about that in this picture. This is the side opposite the given angle. When that side is smaller than the other, this one right here, given side, the 40 is smaller than the 60, then we have something interesting that introduces itself. So let's go ahead though and just solve this problem. And forget that we even knew that was the case. So side B is 40 and side A is 60. And angle B is 30 degrees. So let's go for angle A first, right here. In the picture, I don't know, it looks like 40 degrees or something. So let's go with side A over the sine of angle A equals side B over the sine of angle B. And if you would take 60 times the sine of 30, please, and then divide that by 40. So 60 times the sine of 30 degrees, hit enter or close the parentheses, divide it by 40. I'm going to see if I have that number in my notes. Probably I do not. I'm going to go ahead and type it then. So 60 times the sine of 30 degrees divided by 40 gives me a ratio for the sine of angle A, 0.75. So if I go second sine, second answer, so I'm going to use that ratio, it tells me that that angle that has a ratio of 0.75, its size is 48.6 degrees is what I'm going to write it down here as. This is 0.75 as I recall, and that meant that angle A was, no, I've forgotten, can't believe it, 48.6 degrees by taking the inverse sine of 0.75. Okay. And so I'm going to come over here and put the 48.6 degrees. So I continue on. These two had to be 78.6. Therefore, 180 minus that is 101.4 degrees. And could I just tell you that after you solve for C over the sine of angle C equals B over the sine of angle B, when you solve that for side C, you're going to find out that side C is equal to 78.4. So right here, 78.4. All right, so what's all the fuss about? But wait. This is a little bit hard to demonstrate, and I'll show this probably in class as well. But the picture that we used just now looked like this. Maybe I'll go red. It was this triangle right here. But if this side right here is smaller than that side could be swung over here and put right here, as is shown in this triangle. So the 40 just got swung from here over to here, and we have much different angles now as a result. Look at your picture way up above. Angle C turned out to be 78 degrees. In this new picture, angle C is going to be in the teens. But dang, the data is the same. We still have angle A, angle B, angle C, side A, side B, side C, and we still have a 40 for here, a 60 for here, and angle B was 30 degrees. So when we wrote, I'm going to scroll this up here a little bit. When we wrote side A over the sine of angle A equals side B over the sine of angle B, we found out that the sine of angle A, as I recall, was equal to 0.75. Well, do you remember that all the trig functions are positive in the first quadrant, and that in the second quadrant, sine is also positive along with its reciprocal function, cosecant? So here, the sine of angle A is this positive number again, but angle A is something bigger than 90 degrees. So we found up here that angle A was 48.6 degrees. Well, that makes this angle right here 48.6 degrees. And this angle right here is 48.6 degrees right there. So this angle A right there is going to be 180 minus. So I'm going to write here that angle A, it's a reference angle, is equal to 48.6 degrees. So angle A prime in our new situation is 180 minus the 48.6 degrees, and that gives me 131.4 degrees. And now I add those two up and get 161.4, and I subtract that from 180, and I do get an angle for angle C in the teens. And then finally, I can finish this problem up. I'm going to get a very short side for side C. I'm afraid I forgot to calculate that in advance, so let's just go ahead and do it. So I'll have C over the sine of 18.6 degrees equals B over the sine of 30 degrees. So I need you to type for me 40 times the sine of 18.6, and then divide that by the sine of 30. Getting a little sloppy there. So 40 times the sine of 18.6, and divide that by the sine of 30. And I find out the side C is 25.5, I'm just going to put, is side C. And then I just want to check this. So I'm going to go ahead and take the side A divided by the sine of angle A and see if that's equal to side B divided by the sine of angle B. Dang. So what am I typing wrong? Let's see. Wonder if I got side C wrong. If you don't mind, I'm not going to cut that piece out. What I did wrong was I typed times here. So I should have typed 60 divided by the sine of 131.4. And I'm comparing that to the 40 divided by the sine of 30. And then finally, let's type 25.5 divided by the sine of 18.6 and see if that's close to 80 as well. So all of these were close to 80, telling me that my solution was correct. I'm going to stop here. Might do one more, but I actually might take it to a story problem. We'll talk more about this unusual case during class.